Hi, today we have something different on the bench. This is a music and sound model MC602. And the MC602 is a 90s music and sound master station. This was sent in by a fellow named Toby, and it's missing the faceplate. You have to remove the faceplate to take the unit off the wall, and he chose not to send the faceplate, so you get to see some of the guts of it. Toby sent this in because it has a very specific problem, and I thought that I would have a good chance at being able to fix it. What he described the problem is, it won't play the FM radio. The AM radio works fine, the intercom works fine, the doorbell rings okay, the clock and all of that works fine, but when you try to play the FM radio, all you get is sort of static out of the speaker. It sounds like a radio that's tuned off station to some frequency where there is no radio station, and you just sort of get that background staticky kind of noise all the time. And it does that on all the range of FM radio stations. When you use the seek function, it's a seek tuner, which means it scans up or scans down the FM band looking for a strong station to stop at. It just scans and scans and scans and never stops. One time it did stop at one frequency, but there was no station there, so I don't know if that was just a glitch or maybe there was just barely enough signal maybe that it saw it and stopped. I don't know for sure. It only did that one time. I told Toby that if he wanted to send it, I'd be willing to try to fix it. Have I worked on an MC602 before? No, not really. Do I have a lot of technical information about MC602s? No, not at all. But the tuner designs in M&S Systems are fairly well done, and I thought I would have a pretty good shot at doing it. So let's take a look at what we have here and then talk a little bit about what it probably will take to fix it. So we're looking at the back of the MC602. We have a speaker cone here. This is the terminal board. This is where the wiring from the remote speakers gets connected. An MC602 is a 4-wire system, so you have connections here for the, I believe, green wires from each remote station, and then all of the white wires get bundled up on this binding post. All of the black wires go on this binding post, the red wires go on this binding post, and if your system was installed with music and sound shielded intercom cable, all of the shields, or grounds as they would be, go on this binding post here. Most of the time people don't have that. You've got some audio circuitry down in here. I have not done an extensive look at all of this because my interest at the moment is the tuner. So this is intercom related down here. This is the connection for the chime module. This would be your amplifier section here. Your primary power supply is up here. And right here, this rectangular circuit board, this is your AM FM tuner. Now this has been partially disassembled because I had some free time, and I'm always curious when something new comes along, and I wanted to take a look at it pretty quickly. So I went ahead and removed it from the set and did a little bit of poking around on it because I told Toby that I probably, if I needed parts that I didn't have, I'd have to order them. And anytime in today's world you say I have to order parts, that's a week right there. So we have to like get on it because, you know, Toby wants his intercom back. So to make this a little easier for everybody, you and me, let's go ahead and remove the tuner board. It's partially removed already. And this has a ribbon connector here, and you have to push up on the sort of socket to unlock it enough that you can pull the ribbon cable out of the connector. I guess this is actually more of a flat flex cable. And then the tuner snaps on these plastic standoffs, which I hate. If you've seen any of my other M&S videos, you know how much I hate the plastic standoffy things. So I've already released them so I can take the tuner board out. So let's get this aside. Oh, and underneath the tuner board, these are your auxiliary input jacks. So this would all be auxiliary input audio connection stuff. And controls down here, you got intercom, volume, bass, treble. These are the volume control pots that are connected to the knobs behind the door on the front. So this is not a terribly complex design. It is kind of interesting because the majority of all of this are through-hole parts, which means there's holes in the boards and all the components have little legs that get stuffed through the holes and then soldered. Except right here, we have this little fella right here, U12. This is a surface mount part, and I don't think there are any other surface mount parts that I can see. So there was something about this part that they really wanted to use it. They couldn't get it in a through-hole design, so they went with a surface mount. So one surface mount in all of this, that's not bad. Let's go ahead and put the Master Station aside and take a quick look at the tuner. All right, so here's a close-up of the MC602 tuner. This is the white connector down at the end where the flat flex cable went into. And down here at this end, we have 4 screw terminals. This is where the antenna connections are made. You have 2 screws here for an FM dipole antenna if you're using a 300 ohm antenna. This connection and this connection would be if you're using a 75 ohm connection, which would be a coax cable typically. And here is a single connection for your single wire AM connection. Before I took this out of Toby's intercom, it actually had this metal shield that was soldered onto the board like this in place. And then also there is a cover that goes over it like this. You have to, of course, remove the cover to see what's underneath. And to work on the board at all, you have to get rid of the shield because frankly it's just in the way. Why does it have a shield and a cover? Well, primarily to help block out interference that affects how well the tuner actually operates. So I removed the cover, saved the screws, little tiny machine screws, and desoldered the shield and took it off the board. So now it's much easier to work on. I did what any good service guy would do first based on previous experience working on M&S tuners. I went through the board and I checked all of the diodes. You check all of the solid state parts first. So I checked all the diodes, I checked all the transistors. You have to be careful because like right here, this is Q1, which is transistor 1, and down here you have something else that looks like a transistor package, and it does have 3 legs, but it's actually called D1 because it's a diode assembly. They do that sometimes. Some diode assemblies are in packages that are similar to transistor packages, and that can trip you up if you're not used to it. So I went through quickly, checked the 2, there's only 2 transistors on the whole thing. There are, I believe, 4 diode assemblies. Those are fine. There are a variety of discrete diodes. I went through and checked those real quick. That's all okay. Nothing obviously blown up or anything like that. So at that point, you have to start looking for other possible causes. And usually when you're sort of doing, this would be sort of a shotgun seat of the pants type repair at the moment, you do the things that are obvious that you know perhaps need to be done based on previous experience. And based on previous experience with M&S tuners, I went through and replaced all the electrolytic capacitors because they can be problematic. However, this particular board, this was populated with capacitors made by a company called Rubicon, and they are one of the top capacitor manufacturers in the world. I didn't really see anything that looked bulged or failed or anything like that, so I didn't really hold out much hope, but there aren't that many to do, and I have them all on hand, and it's only like 15 minutes worth of work, so why not? So I replaced all of those, put the set back together, and it was exactly the same. So that leads us down to what should we do next. Since this is a modern tuner, it would have been designed sometime in the early 1990s. You know, it's not a tuner from 1962. It's a modern tuner and is designed like most modern tuners are, which means that it has a variety of integrated circuits here, 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 and here, and each of these do something. Tuners back in the 1960s, if you had an equal tuner, equal in that it tuned AM FM radio stations, not equal in functions, because this has a lot more functions and features. The tuner would be probably 4 times the size and probably be all of 3 inches tall, because components in the 60s were huge, and nowadays you have these specially designed integrated circuits that take the place of handfuls of parts and makes everything smaller, and that's why you can carry a computer around in your pocket that everybody thinks is really a phone. There are 4 integrated circuits on this board. You have this little fella right here, a little bit hard to see right here. This is a little op amp, and voltage to it seems fine. It's unlikely that the op amp is a problem. One of the things you have to think about when you're troubleshooting something like this is the fact that the AM radio works fine and it's only the FM radio that doesn't work. So it's something specific to the part of the tuner that has to do with the FM, not the part of the tuner that has to do with the AM, and most likely not the part of the tuner where it works with both AM and FM depending on which band you're listening to. Because if there's a portion of the tuner that has something to do with processing the signal and allowing it to flow through to the amplifier for the AM side, if that circuitry is working, that circuitry probably also does the same thing for the FM signals, so you can sort of discount part of that. The other thing which you should never do are there are tuners like these have adjustments. There are coils which are here, and here, and then there's other little capacitive adjustments on the board also. Do not fiddle with these. Do not mess with these. These do not drift out of alignment. This is how the tuner was aligned when it was manufactured, so it receives AM and FM and works properly. These are not the problem. If you start twiddling adjustments without knowing what you're doing, you'll get it way off, and then unless you have the instructions that takes you through it step by step of how to do a tuner alignment, you will probably never get it back the way it was when it was new. So it's not these. These are never really the problem. Back to our integrated circuits. So down here you have the little op amp, unlikely to be a problem. Right here you have the next integrated circuit. This is an LM7000, and LM7000 is a PLL frequency synthesizing for electronic tuning IC. This could possibly be a problem. It does deal with both AM and FM. It could be that the part of the chip that has to do with FM has a problem and the AM half still works. However, I'm not convinced that that's actually the problem. So that's this one. Then you have this chip down here, this long skinny black one. That's kind of hard to see right here. This is an LA1177 or an LA1177, and this is an electronic tuner used in FM front ends for car radio and home stereos. This type of tuner, while it's in an M&S Intercom system, an M&S Intercom system is very much mostly like a consumer quality AM FM radio. It does have the intercom functions and other things going on with it, but this is a tuner design that could be used in any kind of consumer AM FM radio, and it's very likely that this board was not actually even designed by Music and Sound. This very likely came from a company that designs and builds tuner boards like this and has them commercially available for other manufacturers who want to incorporate it into their designs. So this could be in an M&S system, this could be in an Audio-Tech system, it could be in your boom box that you take to the beach with you, or some tabletop radio that you bought your grandma to put in her kitchen so she can listen to her talk radio or something like that. It's sort of a general purpose kind of board. So since this integrated circuit has to do specifically with FM, and it's the FM front end. Now, what is the front end? The front end is the portion of the tuner that deals with the signal that comes in from the antenna first. And the front end is important because if it doesn't, and I'm going to use it sort of a generic term here, if it doesn't process the signal from the antenna correctly, then you don't get any radio. That's a likely culprit there. And then we also have this chip right here. This is an LA1266, and this is an AM/FM tuning system for electronic tuning. So this chip here probably has to do with the seek tuning, and perhaps it has built-in memory in it, so when you preset your AM and FM radio stations, they might be stored in this. I didn't really check into that to see too much, because I'm not too worried about that at the moment. So it could be this one also. It's difficult to troubleshoot integrated circuits like these because there's a limited amount that you actually can do. Also, since we don't have a specific schematic for this board, you have to sort of look at the board and in your mind sort of piece together how everything is connected up. However, sometimes you get lucky and there's a better way. So the last three integrated circuits on the tuner board are all made by Sanyo. The other one, the op amp, is made by onsemi. onsemi is now the company that used to be Motorola, or they bought out Motorola or something. All good name brand stuff. Sanyo parts, very common in consumer electronics. They make good parts, they make good integrated circuits. Don't expect to really have a lot of problems with them, but sometimes you do. What I found was when I pulled the data sheets are the informational sheets for electronic parts, and they give you all the details about what they do, how they work, specifications, and so on and so on and so on. And as I was looking through the data sheet for the LA1266, if we flip over to the very last page, what we have here is this. This would be sort of an application note drawing. It says here at the top, sample application circuit for, ready, LA1177, LA1266, and LM7000. Sound familiar? Those are the 3 chips on our M&S tuner board. And what we have here is, we have a sample schematic of how you would connect those 3 integrated circuits together to create an integrated tuner. The company that made this board, whether it was some company that just makes and designs boards like this, or if it was done in-house at Music and Sound in Dallas, Texas, do you think that an engineer is going to sit there and scratch his head and start with a clean sheet of paper and figure out part by part how it should be designed and how everything should work together and read all the data sheets and figure it out and spend weeks and weeks and weeks and weeks on it? Or do you think he's going to go to the Sanyo data sheet, open it up to the last page, and go, voila, there's a drawing, we can use this. And instead of weeks and weeks and weeks and weeks, it's like 10 minutes to figure out what you want to do, and then a little bit of time to make it perhaps work in your application. Either way, this very likely is very, very similar, probably 85–90% similar to what's on this board. So that helps me a lot, because now I have a schematic that shows how the 3 chips get connected together, and it gives me some insight as to where the problem may be. And just briefly, because I have not studied this extensively yet, this right here is where the antenna gets connected. It says loop antenna, so that would be possibly AM and FM. There's also a connection over here that says FM input. That also could possibly be for an antenna. If you sort of generally look at the way the schematic is drawn, this feeds this chip, and it also feeds this chip, and these 2 chips basically feed into this chip. So it's a good starting point, because I haven't actually fixed one of these before, and I'm just like the engineer at Music and Sound or at the tuner board company. I don't want to spend weeks and weeks and weeks trying to figure this out. I want to get it done. I want to figure out what's wrong with it. I want to get it fixed. I want to get it back to Toby. And that's really how a repair shop operate sometimes. You can sit down and do all the mental gymnastics and try to work through the problem, but it's easier to do it instead of dealing with it in theory. You deal with it in real life, or as a friend of mine always says, you repair it in anger, when that means that you're actually sitting there and you actually have to fix it and you're actually working on it. So pick up a tool and do something about it. And that's kind of the approach I like to take. So I did what any good repair shop would do, who has a customer who sent something in that we need to fix. I don't have any of these chips in stock because I don't have any reason to at the moment. So I went online to one of my trusted specialty suppliers, because none of these are currently available. These are not chips that are used in modern devices any longer. They're old-fashioned chips. They're from the 90s. I ordered them from one of our specialty suppliers because they have them readily available, and I know that I can get them in about a week, and I trust them that they're not counterfeit parts or bootleg parts or parts that were taken off boards and they're used. They're new parts and I can rely on them. I did also order 2 of each, because odds are I'll need at least 1 to fix Toby's intercom, and I may need 2 or I may need all 3. I don't think so, but it's always a possibility. And that way I have the parts I need to fix his, plus I have another set for the next guy that has an MC602. And I also would bet that this type of tuner design, if it's used in an MC602, it's probably also used in an MC302, an MC702, and an MC902, because those are all models that were made around the same time. And why the heck would you design 4 different tuners for a series of intercoms all made at the same time? You wouldn't. So they all probably use the same tuner module because that makes cost of manufacturing less. And if this one has a problem, that means that someday someone will call me and theirs will have the problem too. And then I don't have to wait for parts because I already have them on hand. And if it becomes a regular thing where we do enough of these, then I'll order like a dozen of each and have them on hand. And that way, anytime someone sends one of these in, if I had the parts, I could possibly be done with this already, and I've only started horsing around with this like an hour and a half ago. So we'll see how it goes. Anyway, I just thought I would go over that a little bit. Can't do any more on Toby's intercom at the moment, but as soon as the parts come in, which will probably be towards the end of next week or the beginning of the following week, then I'll work on it some more and I'll be back. So stay tuned for the part 2 of fixing Toby's MC602. I hope you found this interesting, and maybe for someone one day it will be helpful. If it is, give us a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.